Solar flare versus coronal mass ejection. Understanding solar phenomena. Solar flares and coronal mass ejections, CMEs, are two distinct yet interrelated solar phenomena that play crucial roles in space weather. Despite their differences, both events originate from the Sun's magnetic activity and can have significant impacts on Earth. Definition and nature. A solar flare is a sudden, intense burst of radiation emanating from the Sun's surface. This burst is caused by the rapid release of magnetic energy stored in the Sun's atmosphere, leading to the emission of X-rays and ultraviolet light. In contrast, a CME is a massive burst of solar wind and magnetic fields that rise above the solar corona and are ejected into space, involving the expulsion of billions of tons of plasma. Duration and scale. Solar flares are relatively short-lived, lasting from minutes to a few hours, with their peak phase occurring within minutes. CMEs, however, can take several hours to days to travel from the Sun to Earth, and the ejection process can last from a few hours to several days. The scale of CMEs is much larger, involving more substantial amounts of material compared to the primarily radiative nature of flares. Causes. Both phenomena are driven by magnetic reconnection, where magnetic field lines snap and reconfigure, releasing energy. Solar flares result from localized magnetic field changes on the Sun's surface and lower atmosphere. In contrast, CMEs involve larger-scale magnetic structures in the corona, often related to the same magnetic reconnection processes but on a grander scale. Effects on Earth. Solar flares can disrupt radio communications, GPS systems, and pose radiation hazards to astronauts and satellites due to the sudden increase in solar radiation. CMEs, on the other hand, can cause geomagnetic storms when their ejected material interacts with Earth's magnetosphere. These storms can disrupt power grids, satellite operations, and communications, while also enhancing auroral displays. Detection and observation. Solar flares are detected using instruments that monitor X-rays and ultraviolet light, such as those on the Solar Dynamics Observatory, SDO, and GOES satellites. CMEs are observed using coronagraphs, which block the bright light from the Sun to view the fainter corona, with spacecraft like the Solar and Heliospheric Observatory, SOHO, providing detailed observations. Magnetic fields. While solar flares are associated with localized magnetic field changes, CMEs involve large-scale magnetic field structures extending into interplanetary space. These magnetic fields can interact with Earth's magnetosphere, causing geomagnetic storms and influencing space weather. Impact on space weather. Both solar flares and CMEs significantly impact space weather, but in different ways. Flares increase radiation levels in the solar system, affecting satellite operations and astronaut safety. CMEs are primary drivers of space weather, causing geomagnetic storms with widespread effects on technological systems on Earth. Conclusion. Understanding the differences between solar flares and CMEs is crucial for mitigating their impacts on Earth. While both are products of the Sun's magnetic activity, their distinct characteristics and effects highlight the complexity and dynamic nature of our solar environment. By studying these phenomena, scientists aim to improve space weather forecasting and protect our technological infrastructure from solar disruptions.